Okay, A.SSE.3.a. This is Algebra, Seeing Structure and Expression, Standard 3, Subpart A, Video 3, Factoring Polynomials Completely. All right, a few terms to know. Please copy these down in your journals and define them. Today we are wrapping up this chapter of factoring, and factoring completely means we need to make sure we're taking an eye on the fact that even though we do a couple of special rules or some quick tricks, we are completely factored all the way down to the most simplest form. And in this example, we see that 2x, the term 2x is being multiplied by this binomial of x plus 4, and also this negative 3 is being multiplied by the same binomial of x plus 4, and we have seen this recently. I guess if I were to write out the way that we've seen it before, it was that FOIL method or multiplying two binomials. And this is the way that you have seen it. So we took our first term in the first binomial and we multiplied it by each term in the second, and then we took that negative 3 and multiplied it by each term in the second, and we were able to come up with our answer. And this is just a shorter way of writing it. So our job is to shorten it. See how it's this long extended multiplication problem? We're going to look for common factors that we can kind of group together to make our life just a little bit easier. So we're done. We're done. That would be it for this particular problem. I guess the special note would be the only way this can happen is if these binomials inside of the parenthesis are identical. All right, now this idea called factoring by grouping, it's kind of what we just did there. We have 4 terms going straight across. We are going to group, actually, we're going to make sure that these exponents are in descending order before we do anything. So we have x to the third, x to the second, x to the first, and this is x to the 0. So we are in descending order. And since there are 4 terms, we can group them by 2's. So I'll take my parenthesis and take the first 2 terms. And then I have the second 2 terms. And then see if there's anything that I can factor out of either one of those binomials, anything that they both have in common. Well, in the first binomial, I have a 1 coefficient and a 3, so I can't really take anything out of there because the greatest factor would be 1. How about the x's? Well, I've got maximum amount of 2 x's, so I could take out x squared, and I'd be left on the inside with, let's see, x squared times x gets me x to the third and plus, what, 3? Because 3 times x squared is 3x squared. All right, then on the other side, can we take anything out of the x and the 3 that's common? So that would be no. So I have plus x plus 3. Okay, now thinking back to that last screen, if we were to kind of shorten this and make it kind of easier to read, I see here that I have a common binomial of x plus 3, and on the outsides I've taken out an x squared, and since I didn't take anything out of the second binomial, there's this invisible plus 1. There's a 1 right here, so we can bring down that 1 and then multiply it by that common binomial of x plus 3. All right, now we're going to get into some problems where we are going to take a look at factoring out the greatest common monomial factor. That's the first step you want to do. And then you're going to be looking for some of those patterns or those quick tricks. After you do that, whatever's left over, maybe there's a trinomial, so you're going to be factoring the trinomial into a product of binomials. And then finally, if there are four terms, we have to recognize that and see if we could simplify that or factor it into an easier looking form. And that is what we just did on that last screen. All right, so let's look at some of these monster problems here. All right, factor completely. According to the guidelines, is there anything that we can take out that's common? The greatest common monomial factor between 3, 24, and 48, I would say yes, we could take out a 3. The maximum amount of W's would be 2 of them. And then let's go back in. So 3W squared times W squared would get me my first term plus 8W, because W squared times W gets me my W cubed, and then plus 16, and that will finish it off on that line. Here comes the completely portion. Sometimes a common mistake of students would be, oh wow, I spent a lot of time thinking about what to take out or what to factor out, and they forget that this inside trinomial is still able to be factored. So we're going to have to recognize that. And I think we have one of our special patterns in there too. So we have our 3W squared. We take our trinomial and factor it into a product of two binomials. And they're both addition signs. We got to recognize that. The ends of our trinomial are both perfect squares. So we know that that's going to break down into W and our pluses. And then what's that perfect square for 16? That would be our 4. Okay. Final answer recognition. Make sure that it is in the simplest form. And we have 2W plus 4s. So let's shorten that by saying W plus 4 quantities squared, because there are 2 of them. Final answer. All right, last one. We're going to take all of these ideas together now, and it says solve the equation. You know that we've been talking about graphing these quadratic equations coming up, finding the roots or finding the zeros. So this is just the computational part, and let's go find out who those zeros are. We have 4 terms. Make sure that our terms are in descending order, to the third, to the second, to the first, and to the 0 power, and they all check out. So since there are 4 terms, let's group them. I have the first binomial, and then I have what? Minus the second binomial. Taking out an a squared would be a nice beginning. So what are we left with? A minus 11. And then we have this subtraction sign. So we have this negative. There's a 9 in common, so I take out my 9. And we go back in. We have an A. And be very, very careful, since we have this negative on the outside and I needed this positive on the inside. A negative times a negative would get us back to that positive 99. All right, what is that all equal to? That's all equal to 0. All right, moving along, let's try to make a recognition of our current line. Okay, I see some common a minus 11s, and I see some terms that have been factored out, so I can group them. We're going to factor by grouping. So we'll take the a squared from the outside, bring down our minus 9 from the outside, and we have our common a minus 11 binomial. That's all equal to 0. use our recognition skills. Maybe there's a pattern out there or a special rule that we've learned, and there is. In the first binomial, we have this difference of two perfect squares. That's called the difference of two squares, and we know that that actually breaks down further. So here's where this factoring completely comes in handy. You have to remember to factor every single line to its fullest. All right, so we have and that was the opposite sign. So a plus 3, a minus 3, and then our remaining a minus 11. And if I were to solve all three of those for a, we're going to have three values here. This a is going to be equal to a negative 3 when I solve for 0. This one is going to be a positive 3. And then the last one is going to be a positive 11. That's the final answer. And if you're wondering how I did all that, think back a video or two when I took each of these terms, set it equal to 0. So I did a plus 3 equals 0, a minus 3 equals 0, and then that a minus 11 equaling 0, and I solved for all three of those. Now if you want to clean up this positive negative 3, which is never a bad idea, we can say a is equal to positive and negative 3 and 11. How about that? All right, in your journals, I'd like you to define the terms on page 2 of the flip chart. Write down any sentences on what you learned from this video. If you have any questions, jot down those questions, bring them to class, and we'll answer them together.